Today we will investigate the inner workings of a Unix-like file system by building our own very simple little file system that stores data not on a disk drive but on traditional good old paper 3x5 cards. So we call this the card file system. So here we have our stack of 3x5 file cards. This being a video, we don't have paper cards, we have pictures representing our cards. The first thing we need to do is to split our stack of cards into two. One set of cards is going to be used for metadata, which is a fancy way of saying data about data, or to keep track of where all the data is stored for each file. The other stack of cards is going to store the actual data that's in the files. Exactly what gets stored in the metadata, which we're going to call inodes, and in the data blocks, which we're going to call data blocks, will become clear as we build the file system and start creating files. For now, we split the deck into two. The light gray cards are going to contain our metadata, and the mauve cards are going to contain the actual data blocks that represent the data inside the files. We've moved our cards off to the corner where we'll have easy access to them. We've also labeled some fields in the inode. We have ID, type, links, and data. ID is simply a unique identifier for the inode, and we'll start at 1 and count up. Type is the type of file the inode describes. We're going to start with a simple F for regular file. Links is a fancy way of saying how many names does this file have. Once we start building directories, the links field will make a lot more sense. And finally, we have a field called data, which contains a list of the data blocks that contain the contents of the file. And you'll see at the bottom, every one of our data blocks has been numbered starting at 1. Now it's time to create our first file. To do this, we need one inode and one data block. We're going to create a standard file containing the text "Hello World." First thing we do is populate the fields in our inode. This is our first file, so we'll give the inode an ID of 1. It's a regular file, so we'll say the file type is F. Believe it or not, we don't have a name for this file yet, so the link count is 0. And the data is going to be stored in data block 1, so we set data equal to 1. And finally, we put the actual contents of the file in data block 1. Now let's create a second file. This file's ID is 2. Its type is F. It's a regular file. Its link count is 0 because it doesn't have a name yet. And this file requires 2 data blocks because it's bigger than the first one. And our data is stored in data blocks 2 and 3. Now we have a file system in which we can refer to files by number. But our life would be easier if we could refer to these files by name. So we're going to create a simple file that maps file name to file ID number, and we're going to call this file a directory. So let's go on ahead and create a directory that names file 1 hw.txt and names file 2 F2. Not very creative, but there it is. So here is our directory. You can see that it has a type of D to tell us that it's not a regular file, it's a directory file. And then in its data, it simply has a list of file name to file ID number. Since this is our first directory, let's make it the root of our file system and draw a file system diagram that matches that. Almost done. Remember I said the link field in the inode counts how many names or directory entries each file has. And file ID 1 now has one directory entry, hw.txt, and file ID 2 now has one directory entry, f2. So we need to update those link counts, setting them to 1. Let's create another directory and leave it empty for the time being. We will then place this new directory underneath our root directory and call it cars. To place cars under the root directory, we need to add an entry to the root directory file for cars, and it needs to point to file ID 4. Once we've done this, we have a subdirectory, cars, underneath the root directory. And we can see that the entry cars in the root directory allows us to navigate from the root down to the cars directory. This is very good, but once we're in the cars directory, how can we get back up to our parent? Well, we can navigate up the directory tree to our parent because we have a special entry in the cars directory. And that entry is ... The ... directory entry points to our parent. So we add an entry to the cars directory, a file named ... that points to file ID 3, our parent. If we do a cd ... when we're in cars, we cd to our parent. Let's create a file named Porsche in the cars directory using this command. After running this command, we have a file with an ID of 5 containing the text "Wee" and a directory entry in our cars directory giving the name Porsche to the file with ID 5. Now we'll give our Porsche file a second name, Boxster, using this command. Notice the new entry in the cars directory and the new link count of 2 for file ID 5. This link count of 2 tells us that there are now 2 names for the file with ID 5. And we can see them right next to each other. They're Porsche and Boxster in the cars directory file. We'll remove the file Porsche by executing this command. We see that the directory entry for Porsche disappears and that the link count for the file with ID 5 goes from 2 to 1, indicating that where we used to have 2 names for the file, Porsche and Boxster, we now only have one name, Boxster. But the file still remains and the data blocks aren't returned to the pool of available data blocks because we still need that data for the file named Boxster. Executing one more rm command, rm cars Boxster, removes the Boxster entry from the cars directory and decreases the link count on the file to 0. The link count going to 0 tells us that we're done with that data card and we don't need it any longer. So the inode card, ID 5, can go back on our stack of available cards. And similarly, because no one is referring to the data card 6, that card can go back on our stack of available cards as well, both ready for reuse. Today we saw how to build a simple file system using nothing but 3x5 file cards. If you want clarification on anything you've seen today, please don't hesitate to talk to your instructor. That's what we're there for. If you'd like an extra challenge, consider how you could implement symbolic links into your card-based file system.